So very good morning. Today we are going to discuss what is the need for the wastewater treatment. So basically for the treatment of wastewater is much needed to kill the pathogens and to remove the unpleasant and objectionable taste and odor present in the wastewater, and to remove the dissolved gases and color of the water, and to make fit for the domestic and the commercial uses, and also primarily to remove the BOD, that means the biological organisms present in the water, and colloidal matters. So it is the treatment from the reservoir to home. So initially we are getting the raw wastewater from the houses and the commercial. Next we are initially screening. It means we are removing the floating matters and rubbish present in the wastewater. Then we are adding the coagulants. So coagulant is nothing but AlSO24 and FeCl2. And then we are going into the sedimentation. So sedimentation can be done in two ways, either by means of coagulation or by means of flocculation. Then filtration, and then pH correction, that means the removal of excess amount of pH and carbonates present in the water. Then adding an anti-corrosive agents and chlorination to remove the organisms or to kill the pathogens present in the wastewater, and then to homes for the recreational uses. So initially we are collecting the raw water in a huge tank, and then in initial stages we are providing the bar screening and the mechanical screening to segregate the floating matters present in the wastewater, and thereby the wastewater reach the next step process, and it doesn't cause any obstructions to hit the wastewater treatment plant on any clogging problems. Next, we are giving an aeration. So aeration is nothing but dissolved oxygen into the wastewater to remove and to promote the to remove the odor and taste. The sour taste, and to help the promote the bacterial growth. That means a good bacteria. So which will result in the bacterial growth will result in the precipitation and the nuisance metals like iron and magnesium. So here I have shown the cascade aerators, which is also placed in the Gangotic water treatment plant, which is present in near the Ganga rivers. Here the water is allowed to flow in a step-by-step manner in the form of cascade. The air is infused inside it. So the next type of aerator is nothing but spray aerator. Here the air molecule, the air is sprayed inside the wastewater with the help of nozzles, so which will causes the bubbles to create, and the bubbles will attract the waste particles present inside the wastewater, and it is being separated. And next one is spray aerator. Spray aerator is nothing but with the help of spraying manner, as like we are using in the agriculture. So it will be sprayed at a rate of 1 meter per second at a velocity. So it's like an injecting, that means injecting the air molecules into the water. So these spray aerators will be helpful for the attraction of heavy and much minute particles present in the wastewater. So there will be also a slate tray aerators also kept. So here in the slate tray aerators, one end is fixed with spray aerators and other end is fixed with the tray aerators. So here in the tray the minute particles will get attracted and it will settle, and the trace can be a removable type, and with the help of removing type of trace we can able to collect the minute particles present in the wastewater. Next we are getting into the bigger topic, that is sedimentation. So sedimentation nothing but allowing the suspended matters to present in the wastewater to get settled down with its own specific gravity, and also the fine suspended matter, thereby reducing the pollutant load into the further treatment process. So initially the sedimentation is done with the help of three processes. So coagulation and flocculation, this is the major process which promotes the sedimentation. And next one is filtration. It is primarily for removing the microorganisms and the colloidal matter present in the wastewater. And next one is disinfectant and softening. So these together called as a sedimentation process, but lately it has been categorized into individual steps. So first step is coagulation and flocculation. Now we are calling up this is as an sedimentation process, and then filtration. The filtration is followed by maybe two types of filter, that is slow slant filter and rapid slant filter, that we will cover in the forthcoming module. And next one is the disinfection, and last one is softening. So in this session we will be discussing about the coagulation and flocculation. So coagulation is nothing but adding a coagulant, so it will create an flocks in the soapy manner, and it will attract the particles, that is suspended particles present in the wastewater. Then we are following up the flocculation. So flocculation is nothing but removing of the flocks present in the top part of the wastewater. In that flocks we can able to find the finer suspended particles which is present in the wastewater. So we are coming to the theory of coagulation. So coagulation, I think, is the destabilization of colloids present in the wastewater by the addition of chemicals. So it will neutralize the negative charges, that means the negative particles present in the wastewater, and also the negative ions also. So the chemicals we are using at the time of coagulation is called coagulants. So it is an essential chemical process that will cause up between the water and coagulant, so which results in the formulation of flux. So the coagulation can be done either by means of natural mixing or by means of mechanical mixing. So here the natural mixing will occur in a slow and smooth manner, but in the mechanical mixing it will be done in the rapid manner. So here we can able to see that there is a baffle walls which is provided in a zigzag manner. So from the one end we are allowing the wastewater to flow through it, and there is a coagulant container which is kept at the starting point, and that coagulant will be added in the terms of 0.5 ml to per liter. So this coagulant will mix perfectly into the wastewater, and then the wastewater along with the coagulant will flow into these baffles and get it mixed. But the mixing machines allow the water to float in a slow and steady manner with less velocity, so it will get mixed very thorough manner, and the coagulants and the coagulant process will start. So this kind of slow and steady mixing is called the mixations with the baffle walls. So next one is rapid or flash mixing. So it means it is purely mixed with the help of a mechanical device. So here a coagulant is added either in the terms of gram per liter or mg per liter, and then we are allowing the mixing process in a tedious way. I mean the speed of the mixing is in a fast manner. So normally it will be mixing at a rate of 30 to 60 seconds per minute. So here the detention period is allowed about like 30 to 60 seconds at the time of mixing, and the head loss of water is allowed for about 20 centimeter to 60 centimeter. So it means we are allowing the water through a thorough mixing with the help of mechanical stirrer, and then later we are collecting those coagulant on the top. For example, if you are having a water of 40 to 45 centimeter of depth of thickness of water, then if you are adding a coagulant, we are allowing the flash mixing with the help of in a fast manner. Then later we are allowing it to float for 60 to 30 to 60 seconds. Then we are going for the thorough mixing. So then we can able to see at the end the water depth of water is reduced to 20 to 60 centimeter. It means the coagulation process has been done in a good way, and then the flocks are formed. Then we can able to remove the suspended solids which are arrested in the flocks. So this will help the rapid mixing. Then slow mixing is nothing but as we seen in the previous slide, it is a mixing with the help of baffles, but here the detention period may be around like 1 to 2 hours, and also the head losses can be seen in much enough. So coagulation aim. So why we are going to for the coagulation means initially we are adding the coagulants. You can able to see the impurities present in the water in the red color, and then we are adding the coagulant, that means a coagulant in the chemical coagulant in the green color. Then these chemical coagulant will react with the water, that means it will react in the oxygen present in the water, and it will get attracted to the impurities. Then it will be settled at the bottom. So this is the process of coagulation. But in the flocculation, these coagulants will be converted into the small flux. It will be floating at the top. So that is the much difference between the coagulant and flocculation. So what is flocculation? We are coming to the next topic. Flocculation is nothing but agglomeration of a destabilized particle into a very large size particle with the help of flocks, which can be easily removed efficiently and also efficiently removed during the time of flotation. It means at the time of sedimentation, initially we are adding up the coagulants, and the coagulants settle at the bottom. But in the time of flocculation, the flocks will be developed. These flocks will collect the larger size particle, and it will float at the top of the wastewater, and those flocks can be easily removed with the help of an machine or physical way. That's why we will be calling it as an efficient way of sedimentation. So this is the mechanical flocculator we have shown. So for example, this is the height of the flocculator chamber, and this is the length. So here we have arranged a flocculation at the top, and we are providing a flocculation in a crossway manner, that is a transway manner. So we can able to see the platforms in the second image, which is shown in the top view. We can able to see the platforms in there. Once the flocks are formed, means the flocculator will rotate and it will collect the flocks and it will remove the flocks, and the wastewater is sent to the next treatment. So further we can able to classify the flocculation process into a number of ways. So the next one is hydraulic flocculation. So hydraulic flocculation is nothing but similarly the flocculation in a natural way. So here also the baffle valve will made to construct, but these kind of flocculation may be done in two directions. One is vertical direction and another is horizontal direction. In vertical direction, the baffle valves are provided in intermediate spacing. So initially the spacing, I mean the gap between is provided at the bottom, but in the next baffle valve at the bottom the gap is arrested and the gap is made to be in the top. In a simultaneous way, the gaps are provided in an alternative manner. For example, initially at the gap at the bottom of the baffle valve, in the next segment the gap will be at the top of the baffle valve, and in the next segment again the gap will be provided at the bottom. So in the simultaneous way we are provided. Similarly for the horizontal flow also. So this is why done, because the water is allowed to have an higher amount of larger time of flow. So it will the coagulant will get mixed and the flocks will be formed in a higher manner. So this allows the water to flow in horizontal direction, also vertical direction. It will break down the water particles. The breaking down of water particles will causes the breaking down of suspended solid molecules and the colloidal particles present in the water, and it will be get arrested by the flocks. So this hydraulic flocculation is the efficient way of removal of colloidal matters present in the wastewater. So this is one of the image we can able to see both the horizontal baffles and also vertical baffles presented. We can able to see initially the water level is higher, but when coming to the another end the water level is much getting lesser. So the water is flowing through a different baffle walls, and then it is collected in the water level chamber. So these are some examples with some we can able to see the baffles which have been provided, and also the gap is provided at the one end and the gap is provided at another. This is a kind of baffle walls we have been using for the flocculators. Here the PVC sheet has been used as in baffle walls. So similarly we can use any kind of things for the baffle walls. Next we are coming to the topic clarifier. So this will be seen in the next class. So thank you. Kindly attend the quizzes.